I am Sumit More, and today I will discuss about my project on scientific calculator in 8085 language. So I have used 8085 instruction to implement my different subroutines. Here I am using addition of 8 bits, addition of 16 bit, and subtraction of 8 bit, multiplication of 8 bit, and division of 8 bit, and finding the square root of given 8 bit data. So I have implemented these 6 operations in 8085 instructions. So I will start from addition 8 bit instruction, addition of 8 bit operands function. So here I have used several registers to simply add my operands using SUB mnemonics, and for that purpose, for taking input, I have used 03 port and 04 port, and from this port I have stored the values in B and my C register, and then I am storing the addition of those I am storing those addition of those operands into memory location C052 and C053, and moving on to the addition of 16-bit data. Here I am using same 034, 03, 04, 05 and 06 port. Here I am using 16-bit data, and this is 16-bit data. The lower byte of a first operand is stored in 03, higher byte of a first operand is stored in 04, lower byte of a second operand is stored in 05, and higher byte of a second operand is stored in 06. And here I am using DAD command to add those 16-bit data. Here the my first operand is stored in HL, and the second operand is stored in my D register pair. So DAD command just simply adds your D register pair data into HL register pair, and then I am checking whether there is carry generated or not. If the carry is generated, then I am simply incrementing my C register's value, which is uh, initialized to 0 previously. So if carry generates, then I will simply increment my C register and go to the SHLD C054 instruction. So here I will store my addition result of that addition in C054. The LSB part uh, LSB part of the my result will get stored in C054, and the MSB part, that means higher 8 bits, will get stored in C055. Now uh, now the carry will be stored in C056 location. Here I have, if it is incremented, then the 1 will go, and if it's not incremented, then by default 0 will get stored in C056. So now moving on to the subtraction 8 bit subroutine. Here I am using simply B register and accumulator to subtract my two 8-bit operands. Here I have used uh, port 03 and port 04 to store my two operands, and then the result that is generated in accumulator will get stored in C052 memory location. Moving on to the next moving on to the next program, that is my multiplication. Once let me just go through my code. Here is my code. The multiplication subroutine contains your first input. Same, the input is also taken from 034, 03 port and 04 port. And one thing I want to mention you, that in subtraction, my higher my the number which is getting subtracted from the number, that means a minus b. So the a part is stored in 04 location, and the b part is stored in 03 location. So that means the number which is getting subtracted is stored in 03, and that means taking input from 03, and the number from which it is subtracting, that is stored in 04 port. That means taking input from 04 port. Now the multiplication subroutine. Here I have used 03 port and 04 port for taking my operands, 8-bit operands, and then I have first initialized my HL pair to 0000, and then initialize my B register to 00 and C register to the value stored in D register, which was storing my input from 03 port. And now I am simply adding BC register pairs value to my HL register pair, which initialized to 00. So this loop will continue until my E register pairs value becomes 0. That means that was my second operand. That means it will add those many times. If those many times, that means it will add uh, if E register contains 5, then the loop will run 5 times. So E register is used as a counter in this subroutine. So the result which is stored in HL register pair. Now this HL register pair's result is stored in C052 and C050 location. The L part will go in C052 location and H part will go in C052 location. Now moving on to the next division of 8-bit operands. Here I am using E register and initializing it with 00 and taking my input from 03 and 04 port. And here my 03 port is my dividend port, and 04 port is representing my divisor port. So here the operand which come from 03 port will be my dividend, 04 port will be my divisor. So I am just simply subtracting the your my input from 04 port from the 03 port until the value which is the final value becomes less than the uh, input data of in the 04 port. That means here my B register is storing uh, the dividend, and C register is storing my divisor. So every time I will subtract C from B. So for that purpose I have used SUB instruction, and as we know SUB instruction works with accumulator. So I have stored that B value into the accumulator and subtracting C those many times until uh, the accumulator value becomes less than the C register, that means my divisor. So if becomes less than that divisor, then we just simply exit and store the value of accumulator into 2000, and the accumulator is now storing the remainder of my division. So it is storing the remainder of my division, so it will go in 2000 location. And now I am moving E to my A register accumulator and E contents to my accumulator, and then storing it into 2001 memory location. This will be my quotient. Now I will explain square root subroutine. In square root subroutine, I am using the logic that sum of your first n odd numbers equals to the n square. That means if I am adding first 5 odd natural numbers, then their summation will be equal to 5 square, which is 25. So I am using this logic to implement my square root subroutine. In square root subroutine, I am taking input from 03 port and storing that input in B register, and then I am initializing D with 00 and C with 01. Now I am iterating loop till my accumulator. I am iterating my loop for calculating the square root of my accumulator stored for calculating square root of number that is stored in accumulator. So first I will move in loop. First I will move content of C register into E, so that I can subtract E register's content through into from my accumulator, and then I am incrementing C 2 times so that I can generate odd numbers, and also I am incrementing D so that I can keep a record of how many loops I have iterated, uh, not iterated, but how many loops I have run till now. So and then I will subtract E register's content from my A register, that means accumulator content, and compare my accumulator with E register's content. If my E register content is greater than my accumulator content, accumulator content, then carry flag will be set and we will terminate the loop, and the D register will have the answer of our question, that is finding square root of 8-bit data. So I am just moving that D register's content in accumulator and storing it to the memory location C053, and hence our program is successfully executed. Now I will run the program to perform all operations. So first we will perform addition operation. So that we need to give input in port 2. First we need to assemble it, and then we will give input in port 2 as 2, and input in port 3 as FF, and input in port 4 as FF, and we will run it all at a time, and we will check what is the result stored in memory. So we got 01FE. My 01 is signifying MSB of result, and 05 FE is signifying my LSB of bit. So the result will be 01 FE. Similarly, if we want to try for some another set of data, let's say for uh, 0f, what will be the output? So we will similarly perform the same procedure, and we will see that we have got 01 and 0e, which is the result of my FF plus FE. So this is how 8-bit addition will perform. So next operation is my 16-bit addition operation. For that purpose I need to give choice as a 3 in input port 2, and I will need here 4 operands, and these 4 operands are LSB MSB of operand 1 and LSB MSB of operand 2. So let's give FFF in all 4 operands. So I have given all 4 operands as FF, then I will run it all at a time and see what is the output. So here we can see that the output is stored in my C056 to C054, and my C056 is storing MSB and C055 is storing intermediate bits, and C054 is storing LSB. So the number will be like the result will be like that, 0 1 F F F E. So this is how my 16-bit additions is stored in memory. Let's perform for another set of inputs. Let's say we will give as 0f to my and here I will give, let's say, 1a. So I will perform run all at a time and see what's my output. So my output is here 2a fe01. As we can see that MSB is 2a, intermediate bits are FE, and LSB is 01. We can also cross check it with the calculator which we got in uh, our PCs. So here I am showing you the addition of my 0FFF with 1AFF. See here in 0F, one second, 0 F FF plus 1 AFF FF. So addition of this will be 2A FE, as we got 2A FE, which is my answer. So the all 16-bit addition operation are performed successfully. Now we will perform 8-bit subtraction. So for 8-bit subtraction, we will have to give 04 as my choice in port 2, and operands will be stored in 03 and 04. And as I have told you that 04 will store my number from which we are subtracting another number. So the another number is stored in 03, and the number from which it is getting subtracted is stored in 04. So we will input let's say FF here, and here we will give input 0 2, and for the rest we will just initialize with 0 0. Okay, and run all at a time. We will see that the output is coming to be FD. The output, remember this, the output for my subtraction 8 bit is storing in location C052. As you can see that in C052 the result is stored as FD. So my subtraction operation is also working fine. So we will move on to another operation, which is my uh, addition and then subtraction, then multiplication of 8-bit data. So we will assemble it and then give choice as 5, and then enter my operands in 03 and 04 port location. Let us give it as FF and FF. So I will run it all at a time and see, and the result will store in C052 and C053 location. So let's see. So there it is stored, C053 and C052 location. The result will be FE01. So higher byte of my result is stored in C053 and lower byte of my result is stored in C052. We can also cross check with our calculator. Let's see here. I will just multiply FF into FF. So here we can see that the result is F01. So we have got our final answer. Now we will try to check for division operation. For division operation we have to give choice as 6, and operand will be given like 03 will be my dividend and 04 will be my divisor. So let's give 03 as FF and 04 as 02. Now I will run all at a time, and my 2000 will store remainder and 2001 will store my quotient of division. So let's see in, no, not 2000 here, my uh, uh, sorry, no, 2000 is storing my remainder and 2001 is storing my quotient. So here we can see that 2001 is storing my 7F and 2000 is storing my remainder. We can also cross check this with our calculator, where I am just dividing FF by 2. So this will store my FF divided by 2. So I am dividing FF by 2. So the answer will be 7F. So we have got proper answer. This is 7F, and my remainder is 01. Now we will check for square root of a number. So square root of a number will be having choice 7, and then we will enter 09 in the port 3, which is input for my subroutine for uh, finding square root. So here the 7 is put it in port 2 and 9 is put it in 03 port. Now I will perform run all at a time and see what output I am getting. So I am getting here 03, and the output which is getting I am getting here is in C053 location. I have told this in my explanation video. So the output is getting C053 for perfect square. It will give us a accurate answer. But if we input some number like 7, so in this number we will get floor value for our uh, input for uh, floor value of accurate answer. That means square root of 7 will be less than 3 for sure, and between 2 and 3 it will lie. So floor value of it will be definitely 2. So run all at a time and we will see what store in C053 location. So C053 is storing 02. So we have got the answer properly. Let's check for 10. So 10 will be 0A in hex. So store 0A, and run all at a time and see what is answer. So answer is 03, which is floor of your some value which will lie between 3 and 4, and our square root of 10 also lies between 3 and 4. So we have got proper values. So our square root subroutine is also working fine. Thank you.